Hi everyone! In today's video, I will be going over the Quarter 1 benchmark review for our Algebra 2 benchmark. So 1 through 3, these problems are review from Unit 1, which is about absolute value equations and inequalities. To do these problems, there is a 4-step process, and my best use of space will probably be about right here. The first step is to isolate the absolute value. And isolate just means to get it by itself. Second step is to make two equations. I like to call it the split. Split into two equations. Then you solve them. And then the last step, of course, is to check your equations. This is especially important with the absolute value equations because depending on the problem, there are a few where they have extraneous solutions, meaning if you don't check it, you will not realize that they're actually solutions that don't work. So first thing we need to do is isolate the absolute value. In our first one here, we can see that this is not isolated. It has a -2 attached to it, so let's get rid of it. For those of you who are tempted, we never distribute into an absolute value. So to get rid of it, we need to divide it off. Always divide it off, never distribute. We're left with x plus 3, absolute value, equals, this is positive 7. From there, we make our two equations. The first equation looks just like the one I already have, except I drop the absolute value symbol. So x plus 3 equals 7, no absolute value. And then the other one, the only thing we change is we make that positive 7 into a -7. Don't change this to a -3. That still stays a positive 3. Just change this number to negative. To solve, we just subtract 3 on both sides. I don't have the room to write that step, so hopefully you can follow what I'm doing. 7 minus 3 is 4. And then -7 minus 3 is -10. Our last step is to check your answer. You can check it with a few things. You could check it with the very first equation that we started with, or you can check it with the equation right before the split. What's important is that you don't check it with either of these because they do not have the absolute value included. You want to use this equation. It's the most simplified down version of the equation that still has the absolute value. So I'm going to check. First, I will check x equals 4. So just plug 4 in for x here. Absolute value of 4 plus 3 equals 7. Absolute value of 4 plus 3 is 7. And then the absolute value of 7 is 7. That works. Now I'm going to check x equals -10. So I plug in the -10 for my x. -10 plus 3 equals 7. Do not drop the absolute value yet. -10 plus 3 is -7, but since it's the absolute value of -7, this turns it into a positive 7. So it still works. So my answers are x equals 4, comma, -10. Write your answers as a comma separated list. One thing I don't want to see is you writing it as a point. This is not the same thing as this. This is a point x, y that you graph on the plane. So we don't do that. And that's it. Number 2, absolute value of -3x is greater than 5. So the process is pretty much the same. It's just going to look a little bit different since it's an inequality. So first thing we want to do is isolate the absolute value. This has already been done for us. This would be where my line would be, and notice that the left side has just the absolute value like we wanted. So now I split into two equations. Again, the first equation is the exact same as the original. You just drop the absolute value symbols. So we have -3x is greater than 15. And then we have -3x. And we not only change this to a -15, but we also flip the sign. So it's -3x is less than -15. Another thing you have to consider is whether we have an and or equation. So our equation here, we have great or than, so this is an or statement. And this or is part of the answer. Now we solve for x by dividing both sides by -3. And then when we divide, we get x on the left. 15 divided by -3 is -5. Reminder, when you multiply or divide by a negative, that flips your inequality. So we have to flip this sign to a less than. Or, repeat on the other side. Divide by -3. X is, flip this sign because we divided by a negative, greater than +5. So this is my answer. One way we can kind of check is with a graph. It's not perfect, but it gives us an idea that we're on the right track. So this should come up as an or graph. So let's see it. We have a negative and a +5, so I'll put 0 in the middle. +5 on the right, -5 on the left. These are open circles since there's no equal to with those inequalities. And then for the arrows, we just look at where the sign is pointing. X is less than -5, this points left. X is greater than 5, this points right. And this is an or graph because they point opposite directions. So that matches what I said I should have. So my answer is x is less than -5 or x is greater than 5. Next problem. 4 times the absolute value of x plus 1 minus 6 is less than 14. The process is the same with just a few extra steps. So the first thing we need to do is isolate our absolute value. So if I draw the line kind of down, splitting it into two pieces, into two sides, you see that on the left side, I have the absolute value over here, but it's not quite by itself yet. So I need to remove the 4 and the -6. We want to add the 6 over first. Remember, we save multiplication and division last, if we can. So that leaves 4 times the absolute value of x plus 1 is less than 14 and 6, which is 20. And then I divide off this 4 to get x plus 1 is less than 5. From here, I still make my two equations. So this is a less than symbol, less than. This is an and problem. Just an FYI, I know I might have some students who are not in my class, so you probably learned this a different way. If you don't like the way I'm explaining it right now, stay tuned. I will show you the other way in just a moment. But for my students, I showed you this way. Split it into two equations. X plus 1, keep it the same, is less than 5. And x plus 1 is, this is where we flip the sign, greater than, make this a -5. Just like with the or, except it's an and problem. And then we solve the same way. Subtract 1 on both sides. Here we have x is less than 4. And x is greater than -6. And then we just need to make sure our graph checks out. So we have a +4, -6. 0 goes in the middle. +4 on the right, -6 on the left. Still open circles. X is less than 4, that points to the left. X is greater than -6, that points to the right. These overlap, meaning we do have an and graph, which matches my and statement. So x is less than 4, and x is greater than -6. For those of you who did not get taught to use the and word, I know you were taught to identify that it was an and statement, but then instead you were taught to write this like this. X plus 1 is less than 5, and then you write the greater than -5 on the other side, and then you just solve both sides at once, leaving you with x, and that would be x is between positive, wait no, you subtract 1. X is less than 4, and then subtract 1 over here, and then that would be -6. And then that's how you would write your answer in the final thing. I hope you understand or realize that these are the same type of answer. It's just this is splitting it up into two separate inequalities. This is a compound inequality. It's the more proper way to write it, but it's no more correct to write it this way than it is this way, just so you know. So I'll write that as another answer choice. So that was 1 through 3. That's review of Unit 1. The next section here is from Unit 2, which is when we talked about our transformations. Questions 4 and 5 refer to the absolute value graph shown. The graph shows g of x is this should be a transformation of f of x equals the absolute value of x. So f of x here, this is the original parent graph. This was the OG graph. And then g of x is the new graph. So this is f of x, this graph is, after we moved it. So we're trying to figure out how did it change. I would recommend answering 5 first because 5 helps you answer 4. State the transformations of the function g of x. In order to get this from f of x to g of x, the easiest thing to do is look at the vertex and see how it changed from here to here. So the original vertex starts at 0, 0, and then this falls in between -2 and -4, so we do interpret this as a -3. And then this falls in between the -4 and -6, so we do read that as a -5. So to get from here to here, it goes left 3, down 5. From here, we can now answer number 4 a bit easier. What is the equation of g of x? It is going to look like the f of x, but it's going to have that transformation included. So g of x equals the absolute value of x. And to give you a little hint here, this is what it's going to look like, this form. I'll go ahead and tell you that I can tell a is 1 here, so we don't have to worry about the a. We just have to worry about the h and the k. H and k come from your vertex, which our vertex here is -3, -5. So h is -3 and k is -5. Remember to be careful here. This is x minus h, and h is -3. Plus k is -5. So if I plug in h and k, this is what I end up with. And then the proper thing to do is to simplify. So I have x minus -3, that becomes a plus 3. And plus -5 is the same thing as a minus 5. So that is the correct way to write our equation. Remember, the h is deceiving, that this lies to you. So it looks like a positive 3, but we actually understand it to be a -3 on the graph. And then k is just k. K does not change. Number 6. Write an equation that shows the transformation of 4 units up, 9 units to the right, and a reflection of the x-axis of the parent function f of x equals a times x minus h squared plus k. So we need to identify where these go in the equation and then put it all together. 4 units up, the letter that moves us up and down is k, so k is positive 4. 9 units to the right, left and right, that's what the h does. 9 units right, that's a positive movement, so positive 9. Reflection of the x-axis. The reflection makes the a negative. So we know a is negative. And that's all they tell us. So let's put all of this into our equation. F of x equals a is negative. Now they haven't given us any other information about a. Since they don't tell us otherwise, we assume that a is 1. So now it's -1. So we can leave the negative out in front, and then we don't have to write anything else because we do understand this to be a -1. If you want to write a 1 here, that's completely up to you. That is still correct. X minus h is 9 squared plus k is 4. And notice now that this h looks like a -9, but again, we understand it to be a positive 9. So that's still worked out the way it should. Number 7, it's the opposite of number 6. Given the following function, g of x equals 4 times x minus 3 squared plus 1, state the transformation from the parent function f of x equals x squared. So now they give us the equation. We have to figure out, based on the equation, how did this change? So if the original was f of x equals x squared, this is kind of like the before, and this is the after. Every new thing that's added here is something to pay attention to. It's a transformation of some sort. So I'm going to list them out. First, we have the 4 in front. Then we have the x minus 3 in parentheses. And then we have the plus 1 on the outside. This gives us 3 transformations. So the 4 in front, when we have a number, and for a, it's either a stretch or a compression. Since this is a number bigger than 1, this is a stretch. Stretch of 4. If it were a number less than 1, typically this looks like a fraction, like 1/2 or 3/4. That would be a compression instead of a stretch. X minus 3, this is a left or right movement. Since this looks like a negative 3, we understand that this is a right 3. Because we interpret this, we read this as a positive 3, the opposite of that sign. So if this is actually a positive 3, that means we move right 3. And then plus 1, we read exactly as it says, that's up 1. And that's it. Back page. 8 through 10 refer to the graph of the polynomial function shown. So parts of a graph is what we're looking at. Number 8, state the domain of the function. The domain, that's your x values. And we get those by reading the graph from left to right on the x-axis. So if you look at the x-axis, which is down here, y is up there, we want to see if this graph skips any values on the x-axis. So first off, I know they're not drawn in, but we can assume here that we have arrows that continue this graph upward. So, to the left side, because we go from negative infinity to positive infinity when we check this, this arrow is pointing up, and it's going to keep going, but it's also pointing up and left. So this is going this direction eventually. So all of the values that are on the far left side of the x-axis, we can't see them, but they do connect somewhere much higher than we can see. So this is covered. So if we follow the graph from left to right, we jump onto the graph right here, and we follow it from left to right. As you can see, as we go left, this graph is solid, and it continues. There's no jumps, gaps, or holes. And then it starts to disappear once we get around 6 or 7 on the x-axis. And because of the arrow, we understand that while it's going up, it's also going to the right. So all of these values over here that we can't see do hit the graph at some point, just much higher than we can see. So what I'm getting at here, there's no jumps, gaps, or holes in this graph, and it keeps going to the left and the right, meaning this domain is negative infinity to positive infinity. State the range of the function. These are your y values. And we get these by moving from bottom to top of the graph. So if we start at the very bottom of the graph, that's our negative infinity. Notice we don't have any graph down here, so our graph will not start at negative infinity on the y-axis. If we move upward, we hit our first point at negative 4, right here. So this is the lowest point on the y-axis. So we start at negative 4. It's a solid point here, so this gets a bracket. And then if we follow the graph upward, it continues going up on both sides here to positive infinity. So it's negative 4 to positive infinity. Number 10, state the coordinates of the y-intercept. The y-intercept, for those of you who don't know, where the graph crosses the y-axis. This is extremely important. If you already don't know this definition, you definitely need to learn it. It's important that you know what this is. So the graph here crosses the y-axis at 5. Now, you can't write 5 as your answer. Your answer has to be a point. So to write this as a point, the y is 5, so x is 0. 0, 5 is the correct answer here. That's it for Unit 2. The last section here deals with systems, 2 by 2, so we've been working on already in class. Solve the following systems of equations. Number 11. Is -4, -1 a solution to the following system of equations? And then they give us our system here. You could solve this and see if the answer matches this one, but a much quicker and easier way to do this problem is just to plug this in and see if it actually works. That's going to be a more straightforward way to get your answer, and it won't require as much work. So let's do that. So I'm going to plug it into the top equation first. We have 5x minus 3y equals 23. 5 times x is -4. Minus 3 times y is -1 equals 23. 5 times -4 is -20. And then -3 times -1 is a +3 equals 23. -20 plus 3 is -17. And as you can see, -17 does not equal 23. Since this did not work, the answer to this question is no. This is not a solution. And we don't even have to check the other equation because it only has to fail once. It can fail both times, and it will. But if it doesn't, it's not the end of the world. It only has to fail one of the two equations for it to not work at all. Number 12, solve the system of equations by the method of your choice. Reminder, we have 3 methods up for grabs. We have graphing, substitution, and elimination. By the way, on your actual test, your problems are going to look just like this. And when I say on your actual test, I mean your test over this unit specifically, over systems. We will give you systems and we will say solve them by however you want, by a method of your choice. But there's always a fastest way. And the problem is usually set up to fit in nicely into one of these 3 categories. This one we would fit under elimination. And if I understand that some of you may not feel comfortable with elimination, but this really is the fastest way. Because not only are these both in the same form, so elimination's easy, the elimination part is actually already set up for us. This is ready to eliminate out the gate. We don't have to do any extra work here. Because on the y's, we have a -3 and +3, which cancel. So when we add straight down, 4x and 4x give us 8x equals 29 and 35 gives us 64. Divide by 8, x equals 8. That took no time at all, and I'm almost done. Don't forget to fully complete the problem. You have to solve for y. You cannot just solve for x. So you pick an equation. I typically go for the bottom one in this case because it is all positives, no negatives to worry about. So we have 4x plus 3y equals 35. So you take your x value and you plug it in here. So now we have 4 times 8 plus 3y equals 35. 4 times 8 is 32. Plus 3y is 35. And I'm already running out of space, so I'm going to come back up here. What I'm going to do, I'm going to do the next step here. Subtract 32 on both sides. This gives us 3y equals 35 minus 32 is +3. Divide by 3 on both sides. Y equals 1. For good measure, I'm going to check my work. You should always do this. It's a very quick and easy way to check mistakes. See if you find any mistakes in your work. When you check, you plug it into both equations. So I'm going to put it in the first one first. 4 times x is 8 minus 3 times y is 1 equals 29. 4 times 8 is 32 minus 3 times 1 is 3 equals 29. 32 minus 3 is 29. So that one works. Now I have to try it in the second equation. 4 times 8 plus 3 times 1 equals 35. 4 times 8 is 32, plus 3 times 1 is 3, equals 35. 32 plus 3 is 35. So 35 equals 35, and that works as well. To write my answer correctly, I have to write it as a point. 8, 1, x first, y second, and I am all done. 2 more problems. Number 13. This one you have to read the directions carefully and follow them exactly as they say. The first equation of the system is multiplied by 3. So I'm going to stop there and I'm going to do that. First equation is multiplied by 3. Remember, when you multiply an equation by a number, you distribute it completely. So that's going to give us 12x minus 9y equals 18. Continuing on. By what number would you multiply this second equation to eliminate the x variable by adding? So if I bring this equation over underneath it, 6x plus y equals 10. The question is, what would I have to multiply this 6 by so that I make these x's cancel? Well, in order for these x's to cancel, I'd have to have 12x and negative 12x. So I've already got the 12x on top. I need the negative 12x on bottom. To get this 6 into a negative 12x, I would multiply this 6 by negative 2 to get negative 12. That's what I'd have to do. So my answer is negative 2. For those of you who seem taken aback by this answer, let's go back to what the question was. By what number would you multiply the second equation to eliminate the x variable by adding? So they're asking me, what do I have to multiply the bottom equation by to make this cancel out, to make it work? That answer is negative 2. Negative 2 turns this into negative 12. Negative 12 and positive 12 cancel, which is what they're asking me to do. So I don't have to keep solving. That's all I have to do. One more problem, number 14. There are 180 animals in the barn. Some of the animals are chickens. Let me backtrack here. 180 animals. We have chickens and pigs. And then if there are 476 legs in all, how many of each animal are there in the barn? So let's pick out our variables first. We're talking about chickens and pigs. So C equals number of chickens. And P equals number of pigs. If you prefer other variables, you like to stick with X and Y, for instance, that's fine. Now we need to form 2 equations. So we've got 2 totals here. We have 180 and we have 476. So we're going to make 2 separate equations. This top equation, normally we have 2 types of equations. I typically call them the money equation and the number of items. So here, we don't necessarily have that going on. We have 180. That's just the number of animals. So instead of number of items, we have number of animals. And then the other equation, like I said, most problems deal with money or something of value. So in this case, we don't really have money. You could kind of compare it. Here we're talking about number of legs, where each animal brings its own number of legs. So it has, the label is very different from money, but it's the closer thing you can compare it to, I guess. So this one is a total number of animals equation. So to get 180, you count the number of chickens and the number of pigs and add them together. So this first equation is just C plus P, the total number of things, in this case animals. Now legs, we have to separately consider how many legs does each animal have. So if we're talking about chickens, we're talking about 2 legs per chicken. Whereas if we're talking about pigs, we're talking about 4 legs per pig. This is our system of equations, and we do have to figure out what the answer is. I don't know about you, but I definitely don't have enough space here. So I'm going to grab a new piece of paper to continue my work on. You can solve this however you like. The math is going to be a tad wonky just because of these large numbers, so there really is no correct way to go about this, but you do want a calculator handy for sure. So I prefer elimination in these problems because they're always set up in the standard form. To make this cancel, if I have a positive 2c, I want a negative 2 here, so I'm going to multiply this top equation by negative 2. When I do that, make sure I fully distribute through. So this is negative 2c minus 2p equals negative 360. And then that's the top equation changed. Now I'm just going to bring that second equation down underneath it. 2c plus 4p equals 476. So that I can do the elimination. The 2c's cancel like I wanted them to. Negative 2p and positive 4p, that gives us positive 2p equals 476 minus 360. I feel like that's 116, but I also feel like I'm wrong, so let me check that. Let's see, negative 360 plus 476. Let me fix the brightness here. That's better. 116. Okay, if I divide that by 2. P equals 58. So there are 58 pigs. Now let's figure out how many chickens there are. So you can plug the P58 in for either equation. I'm going to go back to the originals, not the ones I've changed. I would go with the top equation here, less going on. So we have C plus P equals 180. So I'm taking that P value and I'm plugging it in right here. So now I have C plus 58 equals 180. And all I have to do is subtract 58 from both sides. C equals 122. So if my math is correct here, I have 58 pigs and 122 chickens. Last thing we need to do is check and make sure I didn't make any mistakes. So we're going to plug that answer into both equations. Running out of room over here. There we go. Let's check. So I'm plugging these back into the original two equations. I'll check the top equation first. That one should definitely work since that's the one I just used to find C. So first equation was C plus P equals 180. C is 122 plus P is 58 equals 180. 8 and 2 would give us 10, 5 and 2, 7, 8, 180. If you need a calculator for that, feel free to use it. That one worked out. Let's check the second equation. 2C plus 4P equals 476. Plugging in, we have 2 times C, 122, plus 4 times P, 58, equals 476. And then I just simplify. 2 times 122, that's 244. Plus 58 times 4, that is 232. And that should equal 476. Let's check. 4 and 2 is 6. 4 and 3 is 7. 2 and 2 is 4. That came out as it should. So my answer is correct. So for my final answer, I will write 122 chickens and 58 pigs. And that answers the question, how many of each animal are there in the barn? Alright, that is all for the study guide, and that'll be all for this video. If you have any additional questions, feel free to come see me in class or email me prior to your test, or email your other teacher, your teacher if you are not one of my students watching this video. I hope that this video was extremely helpful. Otherwise, I hope you have a wonderful day. Bye!